Welcome aboard, trainees. Today, we're diving into an explainer of the IMO guidelines for dynamic positioning systems. We'll be looking at exactly how absolute redundancy keeps us safe at sea. You know, as a new operator stepping onto the bridge, you're taking control of some seriously high-tech gear that keeps these massive vessels pinned exactly where they need to be, even when the ocean is throwing its absolute worst at you. Your mastery of this stuff, it's literally the ultimate safety net. Okay, here's our game plan for today. We'll cover DP equipment classes, fault tolerance and redundancy, the intense rigor of Class 3 systems, consequence analysis and polar plots, daily operations and checklists, and finally, how to handle critical failures. Let's jump right in. Let's kick things off with Section 1, DP equipment classes, or as I like to call them, your 3 lines of defense. Take a look at how fault tolerance ramps up across these 3 classes. Now, in Class 1, a single fault might mean you lose position. Not ideal, right? But look at Classes 2 and 3. For Class 2, a single fault and an active component, we're talking things like generators, thrusters, or switchboards, won't knock you off position. And Class 3, it takes it to a whole new level. You won't lose position even if active or static components fail. Heck, the system is designed to survive a fire or flooding in any single compartment. Moving right along to Section 2, fault tolerance and redundancy. So this brings us to a sneaky little concept called hidden failures. As an operator, you're going to rely heavily on automated hidden failure monitoring for Classes 2 and 3. This automation is like your watchful co-pilot. It's constantly testing standby equipment, protective functions in those switchboards, and backup power before you actually need them in a crisis. It's a continuous diagnostic check to ensure your backup systems aren't just giving you a false sense of security. The IMO is crystal clear on this next point. Absolutely no single accidental slip-up by you at the control panel should ever lead to a loss of position in these higher classes. The system is literally built to guard against human error just as fiercely as mechanical failure. But hey, remember the ultimate resilience of this system? It totally depends on you knowing its boundaries inside and out. All right, Section 3, the rigor of Class 3 systems. Here is the absolute core of Class 3. Strict physical separation of your redundant components. We're talking backup computers, power systems, even piping, all separated by A60 class fire divisions. And if these systems are sitting below the waterline, they have to be in totally separate watertight compartments. So if fire breaks out in one room, or one compartment floods, doesn't matter. Your vessel is staying right where you put it. To feed data into those backup brains, you need a minimum of 3 independent systems for your essential sensors. That means heading, vessel motions, and wind speed and direction. And here's the kicker for Class 3. One of each of those sensor types has to be wired directly to the backup DP control system, tucked safely behind that A60 fire boundary. So, even if the main DP system completely burns out, your backup is still getting crystal clear, uninterrupted environmental data. Let's jump into Section 4, consequence analysis and polar plots. Meet your new best friend, consequence analysis. This piece of software is constantly playing out worst-case scenarios in the background. If it suddenly throws an alarm, it's basically warning you, hey, if our biggest generator or thruster fails right this second, our remaining power won't be enough to fight the current wind and waves. It's your ultimate risk assessment tool, constantly asking that terrifying what-if question so you don't have to. Hand in hand with that analysis, you'll be checking your DP capability polar plots. These give you a quick visual snapshot of your vessel's ability to hold position against wind, waves, and current from a full 360 degrees. By comparing your fully operational plot with a worst-case failure plot, you can instantly gauge exactly what your ship can handle and set really strict limits for whatever mission you're on. Now for Section 5, operations, checklists, and weather. Okay, how does a shift actually start? Well, you'll kick off with your activity-specific operating guidelines, or AOG, to establish your limits for the day. Then you run through a pre-start checklist, confirming thruster readiness, testing backup comms, and double-checking your DP setup mode. Then, throughout your shift, you're running regular watchkeeping checks, things like verifying power loads are normal, matching up sensor data, and checking UPS battery health. This structured, continuous checking, that's what keeps your safety loop totally bulletproof. Now here is a make or break question for any operator. When the weather goes south, when do you pack it in? You must safely terminate operations the moment consequence analysis warns you can't survive a single failure. But more importantly, you always have to factor in your time to safely terminate. If wrapping up your underwater work takes 30 minutes, you've got to anticipate the weather and start packing up way before conditions cross your post-failure limits. And finally, Section 6, Responding to Critical Failures. Imagine the main DP control system just completely bites the dust. Your immediate, absolute lifeline is the independent joystick. This little beauty gives you completely isolated manual control, complete with automatic heading hold. It's got its own dedicated power supply and sensor inputs, so whether a virus, a software crash, or a massive power surge wipes out the main DP, you still have the physical means to manually stabilize that vessel. Now picture a sudden, totally catastrophic blackout. Boom, main generators go offline. In this nightmare scenario, your dedicated uninterruptible power supplies, your UPS batteries, are mandated to give you exactly 30 minutes of uninterrupted juice. That's your golden window to manage the crisis, fire up blackout recovery procedures, and secure the safety of the vessel and everyone on board. So what happens if the main computer system dies in a Class 3 setup, or if your monitoring spots a critical glitch in the backup network? Now, normally, automatic switchovers happen on the main bridge, but if that entire station is compromised by fire or a massive failure, you've got to get moving. You physically relocate to that backup DP control station behind the A60 bulkhead, and you manually hit that switchover button on the backup computer to take full command. Technology gives us this incredible redundancy we've looked at today. The sensors, the fire boundaries, the consequence analysis. But the true safety of the vessel, it doesn't just come from the hardware. It comes from your operational readiness, your discipline with those checklists, and your absolute mastery of these systems. So if a single failure can't compromise your position, are you prepared to be the ultimate failsafe? Stay sharp out there. Trust your training, and thanks for joining me for this explainer.